everyone. I'm going to talk to you about 3.8, which is Newton's method for finding roots. You know, we have methods. If something's quadratic, that we could use the quadratic formula to find the roots. If it's cubic, there's a formula that will work for some polynomials to find the roots. It's kind of a difficult formula, but it's possible. If it's fourth degree, it's difficult, but higher than that, it is extremely difficult, and it's been proven that there's not going to be any easy formula. Newton's method will approximate those solutions, and so that's a pretty good thing. If you hear bang, 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 my husband's out putting together a more comfortable chair because he's working from home now too, that's what's going on out there. So the basic idea of Newton's method is that you guess a solution, and where the graph might cross the x-axis, so this x naught would maybe be my initial guess of something that's going to cross over here. And so you just can choose anything. Of course, if you have a good graph like this, you would probably choose something closer, but this is just so that you get the idea. And then what you do is you look at your y value and you find the tangent line through that y value for your guess. And when you find that tangent line, you write it to the x-axis, and that's your new guess is what it is. And then you find the y value on the curve, and you find the tangent line of that y value, and you write it to the x-axis, and you get your you get your next guess, and etc. until you hone in on that root. And you can actually get quite accurate. And it is something that's better for a computer to do than for people to do with a calculator. But we're just getting the idea of how it works. But it's definitely something that you would do with a computer. If you're interested, you can go here and you can look at it, look at a demonstration of it. You can type that in and look at a demonstration of it moving. So this picture here in movement of doing it. And so here's the basic strategy of using Newton's method. You start with an equation and you want 0 on one side. So just like if you were going to solve a quadratic equation, you would start with 0 on one side. And you start with a guess. Our book uses x1, and I just kind of said x sub 1, or and I said that many books use x sub 0, or called x naught, to represent their initial guess. But it doesn't matter what you call it, but I'm going to go with what our book does. But obviously this didn't come from our book, and that's why I was saying that some books use the initial guess to be x naught, and our books use x1. So okay, and then you evaluate f of x1. Is it 0? If it is, then you actually found the solution. If no, then you would use this formula right here. This is x sub n plus 1 equals x of n minus f at x of n divided by f prime of x of n. And I kind of like how this was put here, something on the internet, of course, but your new guess is equal to your last guess minus your function evaluated at your last guess divided by the derivative evaluated at your last guess. And then you would circle back. So you use the formula that gives you a guess. Is my guess 0? My guess is 0. Then I found the solution. I can quit. And so if not, do it again and circle, circle, circle. I often don't find where it's 0. I'm going to show you something else I do because I'm a calculator person, you know how that goes. But certainly if I'm doing this step by step by hand. Okay, so this is problem. My son, big shout out to Kevin, thank you. He made it where I can see what's on my video screen more easily. So that I won't be writing off my screen as often. And so that's really helpful. So this is problem 14 in your book, and they want us to explain how we know that the given equation must have a root in the given interval. And so they've given this equation, and they're wanting us to tell them why we know that there would be a root between 3 and 4. And what you have to do is you have to find, so this is my function, and you have to find f at 3. That's what you need to find to start off with. And so I'm going to put that in my calculator here. So -2 times, and I'm putting in here -2 times raised to the 5th plus 9 raised to the 4th minus 7 raised to the 3rd minus 11 here, and we're plugging in 3. And sometimes you say to yourself, why did I pick this example? That's going to be so many things for me to put in my calculator. So I am feeling a little like that right now. I hope that you guys are going to check it with me. And so don't just watch, get your calculator out and be calculating. So here I am putting it into my calculator. I'm here, and now I'm at plus 9 times 3 raised to the 4th minus 7. And I know that 3 to the 3rd is 27, but the reason that I'm putting it in my calculator is that I'm going to use that I put in 3 and just edit it. And so if I have not made any mistakes, that's equal to 21. And I actually don't care that it's equal to 21. What I care about is it positive or is it negative? So I'm going to backtrack through here, and I'm going to find f at 4. So I'm plugging in here. So when I did f at 4 in the same equation here, I got 236, negative 236. So I used that same equation, right, but with 4. And so there's a theorem that says that if this is continuous, and it is, it's a polynomial, and on an interval 3 to 4, if one side is positive and the other side is negative, that somewhere between 3 and 4, it must cross the x-axis. It must be 0. And so, and at this moment in my little life, I'm thinking, well, what theorem is that? And I'm all, I've had kind of a interesting day, and but my thoughts are all out on the name of the theorem. I think it's like the intermediate value theorem, but then I'm questioning myself. Anyway, I think it's the intermediate value theorem, but it has to be continuous, one side positive, one side negative, then you know it crosses through 0. So that's how, and we're supposed to find the root. So we know that there's a root in between. So they want us to use Newton's method to find the approximation of the root corrects to 6 places. And I want to just show you the process, and then I'll show you how you can do it on your calculator. And so we need to start off with some guess. And I told you guys, hey, don't be worried about the initial guess because I will give you the initial guess. Makes it easier for me to grade. Wink, 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 if you can see me winking. And so we're going to guess an initial guess, and I would let you guys pick it. So, but somewhere between 3 and 4, we would like to choose. And so would 3.1 be good, or you think I should guess 3.5 or whatever have you? Okay, you talked me into it. 3.4. Okay, and so now what I'm going to do is I want to find f at x1, which is f at 3.4. So I already have that kind of going on my calculator here. And so 3.4 I'm putting in. In all these places. And you could have chosen anything you wanted in between there. So make sure so I get negative 18.53, and this is carrying around a bunch of places, because if you round, it won't give you the right answer, and that's why you do want to do it on a calculator or on a computer, so that you don't have to have rounding error. Now I also want to find f prime at x1, and so I haven't even found the derivative here, and so this was my f, and so I'm going to write my derivative right up here. So f prime at x equals, is it negative 10 x to the fourth? I really miss my friends that help me and keep me on track and make sure that I don't make any boo-boos. Doing these by myself, knowing that I could make a boo-boo at any moment and not have someone say, hey, wait a minute, you need to be more careful right there, or you made a sign error, or are you sure, is been pretty obnoxious. Okay, so now I need to, so I miss you, I miss you, I miss you. So now I need to put that in, negative 10 times 3.4 was our guess, raised to the fourth. So I'm putting my guess, 3.4, into f prime. And so plus 36. And yes, I'm going to show you how to do it on the calculator. If you're already, if you're watching me put that in my calculator wrong right there, if you're already having an idea of how you could put it in your calculator, then I say go right to it. That sounds good. Don't wait for me. Okay, raised to the second and minus 11. So, and my calculator gave it to me as a fraction, and if it gives it to you as a fraction, that's actually easier to put it in, and so I'm going to write it down here as a fraction too, than as a decimal. And so I keep the fractions as long as possible if I'm writing it out. Now, my next guess, which will be x2, is my guess minus f of my guess divided by f prime of my guess. And so I've kind of got all these numbers out here, right? 3.4 is my guess, minus negative 18 divided by negative and that fraction, right? And so I'll be able to put all of those things in. And I do know there's a quick way of getting it in our calculator. I'm going to show you that next. And so right now I'm just so you have the idea. And so I need subtract, I need a fraction. The numerator is negative 18.53. So yes, this does introduce error when you're typing it in, because there's a good chance that you could make a typo when you're putting it in. And so I am going to show you next how to do it without typing it into your calculator all the way. So this gives us our next guess of 3.294, and you don't want to round, it goes on, right? And I'm just putting dot, dot, dot because we're going to do it on our calculator, and we'll be able to figure out what it is. And in fact, the next number is an 8, so I feel like if I'm going to stop writing, I should at least stop writing at a place where I'm not introduced rounding error. So they're asking me to take it correct to 6 decimal places, so let me show you how to do that. So what I do is on a Casio calculator, I'm sure there's ways of doing it other than with a Casio calculator. You can do it with any kind of calculator. But I put my initial guess, 3.4, and I hit equal. And that becomes my answer. So I can use my answer button. And then what I do is then I know that my formula needs to be this. So I'm going to put my answer minus, and then f of my answer in the numerator. And so, and then remember f was this. So that's negative 2 times my answer. I guess I don't need parentheses, so I'm not going to do it. Answer raised to the 5th. And I got 55 in there. And then I was going to tell you guys the wrong answers, and you were going to say, what did you do? Not plus 9 times your answer raised to the 4th, minus 7 times your answer raised to the 3rd, minus 11 times your answer. And then in the denominator, we need f prime. So here's f prime. So we're going to use it. And so that's going to be negative 10 times our answer raised to the 4th. And you really kind of have to kind of look at carefully what you have. And I am going to try to do that here. It's a little bit like if I look carefully at what I have, then it's like all this time wasted. And I feel like the people won't give me likes or something if I do that. Somehow I messed up there. I don't know what I got in there, but it wasn't right. So 36, the answer raised to the 3rd, minus 21 times the answer raised to the 2nd, minus 11. So I've really put that in there, and I can kind of try to go and make sure that everything looks good in the denominator, and everything looks good there in the numerator, I think, and I hit equals. And when I do that, it gave me, so that was 3.4 was my x1, it gave me my x2. So one time of doing equals, and you can see that it's the same thing we had before. So they wanted us to be correct to 6 decimal places. So when I hit equals again, that's now x3. And so there's x3. And now I'm going to hit equals again. There's x4. And I'm going to hit equals again. There's x5. But you notice something is that it didn't really change that much, right? And so we're having, those places are all there. 6, 3, 7 there at the end. And at this point, I'm more accurate than the places I have on the screen. And I only had to hit it a few times, and it just did the algorithm, right? And so accurate to 6 decimal places. I don't know which one it was because I pushed equals so many times, right? But I know that Newton's method is saying that my solution, x, is approximately equal to 3.27447, 1, 2, 3, 4, 5, and the next number is a 2 and then 6. So it's our value is 3.274473 is the answer correct to 6 decimal places. And so there we have that. And it doesn't matter which x that was through the algorithm because I used my calculator, so I kind of even lost track of that a little bit. Okay, so we did a lovely job there at finding that. What I usually ask, because there's people who don't have calculators that can do it on a calculator, and what I usually ask people is I give you x1 on an exam, and I ask you to find x2 and x3. And that way it can be done, and I make the numbers so that it's not crazy to find x2 and x3. And so anyway. Okay, so this one, and in the book, he hasn't been careful to make the numbers so it's not crazy. So use Newton's method to find all the solutions of the equation correct to 6 decimal places. X to the 3rd equals cosine of x. So we're going to give a try to doing that one there. And the first thing that you might notice is that we don't have 0 on one side. And so if we want to use Newton's method, a good thing to do would be to put 0 on one side. So we're going to do that. So this would be x to the 3rd minus cosine of x equals 0. And then we're going to call this our f at x, right? And so there's our f at x. And then we need our derivative, but our derivative is pretty easy here. It's not too bad anyway. And so 3x to the second. And then the derivative of cosine, without my friends to help me, it's negative sine, right, of x. And then negative times a negative is going to make a positive sine of x. So there's my, there is my derivative. And so what I'd like to do, what I'd like to do next is I would like to, I look over to make sure that I had it right. And of course, I did the same thing earlier this morning. I looked at a different problem and I was thinking, how did they get their derivative to be sine of x minus x to the second minus 2? And because I don't want to make any boo-boos without you guys to help me here. And so now I'm going to put this in my calculator, but now I need to get an initial guess. And I told you guys you don't have to really worry on the exam about making your own guess because of the way I do it, just so that it's easier on people that don't have a good calculator. I tell you x1 and ask you to find x2 and x3. But they're asking me to go correct to 6 decimal places, so I definitely need to use a calculator. And so I want to pick something that seems kind of reasonable. And so if you wanted to pick, you know, something like pi or whatever have you, you could definitely do that. I don't know, pi over 2, whatever you wanna, whatever you think would be good. And so without anyone to help me and tell me what I should choose, I feel at a loss to choose something all that breathtakingly good. I think I'll choose 1 or 1.5, whatever you want. So I'm going to choose x1 to be 1. I noticed that that's what they used in the book, and that makes me feel happy, and so I'll do that. So you just put 1 in here and make sure that it's now your answer. And then remember the formula is your guess, which is the answer, minus, and then a fraction, and then f, right, which is x to the third. So that's the answer raised to the third, and then minus the cosine of your answer. And this is a good time to make sure that your calculator is in radians. If anyone's been using your calculator to do physics, it might have got, your calculator might have got in degrees. So 3, and then the answer raised to the second. I can't think of a time in my class when your calculator needs to be in degrees. There might be, but I certainly can't think of a time. So it's more often than not that it's going to be in radians for our class. Okay, so once I put that in carefully, then all I have to do is hit equals. And that gives me, that's my x2, I guess. And they said to go to 6 places. So I could start writing these down, x2 equals 0.88, but I'm usually too lazy to do that, you know what I mean? And so certainly if I had asked you, though, to find x2 and x3, you would want to carefully find those. I'm going to put a 0 here in front of that before I get too many math teachers sending me emails about that. And so if someone asks me to tell them x2 and x3, then there's x2 and x3. That wasn't the question here. The question here was be accurate to 6 decimal places. So I usually just hit the equal sign, making it do it, until none of the numbers on my screen change. And so that would give us x is approximately equal to 0.86547. There's 2, there's 4, there's 5, and there's a 4, and the next number was a 0. So this is our x, what our x is approximately equal to. So we did a nice job on that, and that's Newton's method. So it's not too hard. You'll probably get to write some computer programs on Newton's method if you take a programming class. It's almost always one of the first things that they do. And so anyway, Now, there's always pitfalls in everything, or maybe there's not always pitfalls, but there can be pitfalls. And so this is a pitfall of Newton's method, is if you have a curve. So here's my root right there. But this has this local min over here, and I guess something over here. And so I've kind of gotten in this web of tangent lines where it doesn't look like I'm ever going to get over there to that solution. And that can certainly happen with Newton's method. And here we have a vertical tangent. And so we're trying to find that, that point right there. And we actually made a pretty good initial guess. But as you know, you can see that as you follow it around, you're actually getting further from the solution. And there's other pictures of just what could happen that you would just, you know, I'm trying to find the solutions right here, or the solutions, and I'm just bouncing around, not getting to them. And so there is some things. If you were wondering, you know, this formula, you know, it's so tricky. But you know, I'm going to tell you, it's just the tangent line. And so I have that on the back over here. I have this t-shirt, You Can Do It. I have a t-shirt that says, We Can Do It. And so I'm trying not to have the cartoons come on the screen because my son said that they'll ban me off of YouTube or something. Anyway, if I wanted to develop the formula, it's just the tangent line. So the tangent line is y minus f at xn equals to the slope f prime at xn times x minus xn. So there's the tangent line, and if you want to just find the x-intercept, then what you do is that you substitute in y equals 0. So into the tangent line that you have, you substitute in y equals 0, and so this gives you 0 minus f at xn minus the equals the slope xn at xn times x minus xn. And how you find the x-intercept is you solve for x. So we're going to find the x-intercept by solving for x here. So what I could do is I could divide both sides by the slope here. So if I did, and 0 minus this is just this. So this would be minus f at xn divided by the slope, xn, and equals x minus xn. And then I could add xn to the other side of the equation. So I get xn, when I add that to the other side, minus f of xn, minus over the derivative here, equals x. And this x right here represents my next guess. And they call that x of n sub n plus 1. Ooh, I got off the screen. Did you see that? Even with the invention, I got off the screen because I wasn't paying attention. I was so worried about covering up my cartoons and whatnot. Okay, so that's the end of chapter 3.